Alright, so before I reveal Josh's techniques, I'll talk about what we've done before. So, with this last example, we had the probability that x equals 0. This is the best case scenario. So when you're dealing with tech free, you will have to do a lot of x equals 0 and x equals 1. Why do you think that's the case? Pardon? Yeah, they're nice to us, and these problems can get pretty out of hand pretty quickly when we've got x equals 6 out of 10, for example. Because if I have this to the power of 6 and this to the power of 4, would I expect that many of us could do that in our head? So you get a lot of examples where you have to calculate power of 0. So it's pretty, in tech-free examples, we're going to learn a tech-active, which will make all this pretty redundant if it's tech-active. But for tech-free, it's really important that we understand the case where 0 is the number we're looking for, and I'll talk about why in a sec. Are we happy with that setup? We got that? Okay, 3C0, 1 to the power of 4, 1 over 4 to the power of 0, 3 to the power of 4 to the power of 3. Good. I guess the only real learning is this, the only point where you can get caught up from this area, once you get that line, is this part here. And it's in understanding that when we've got 3, 0 or 3, 3, the answer's 1. Just like before we did this first example, this 3C3 was 1, and that's because 3 factorial over 3 minus 0 factorial is just 3 factorial over 3 factorial. And the key takeaway is 0 factorial is 1. Awesome? Now why does that happen when we've got 3C3? Well, remember that's equal to 3 factorial over 3 minus 3 factorial, which is what? What's 3 minus 3? 0 factorial by 3 factorial. So it's the same thing, it doesn't matter whether we've got 0 or 3 as the bottom value there. Cool? Just be aware of that. So in this situation, we cancel those out and we're left with 27 on 64. And then I posed a brilliant question thinking, oh, I'm going to make them suffer. And then Josh ruined it for everyone. Thanks, Josh. So what I was hoping you would do was suffer maximally, because I've essentially asked you this. Now what's different about this situation? There's more than one value, correct? This equation only works for equal. So I was hoping that Brad would sit there and go, I know how to do this. I'll go px equals 1 plus px equals 2 plus px equals 3. And I was hoping he'd go through and do this process for every single one of those numbers. And I was going to let him go for about 10 to 15 minutes, and then we'd get to the end and I'd go, no, that's not how you do it actually. Now you could do it this way, nothing wrong with that, correct? Why don't we do it that way?
Excellent.
A lot of time. So what Josh has decided to do, and Josh is going to explain it to us. What have you done, Josh?
He's actually going to draw it on the board.
No, it's alright, I'm going to draw it on the board.
Oh yeah, one takeaway probability x is 0.
So he just said, well, why don't I just look at the probability that that doesn't happen and take that away from 1.
Brad didn't think of that.
Brad didn't think of that. Brad's still on PX equals 2. He's still sitting there going, yeah, I can get there, I can get there. You just got to believe. Okay, so what Josh has said is, look, I know that this probability, greater than 1, is just saying everything except for the probability that x is equal to 0. So I'm going to use my complementary probability. I'm going to take 1 away from that probability. I've already calculated that, so it's just 1 minus 27 on 64, which is 64 on 64 minus 27 on 64, which equals, Brad?
30,
33?
I can believe no.
37.
No, it's not. Yeah.
Brad's right, it's 37 on 64. Cool? Happy with that? Quick maths. That is quick maths, because we could go about it by doing each one of these, or we could do the 1 minus situation. So again, the sort of thing that we'd ask in a tech-free exam is, what's the probability that Brad flips more than 1 coin, at least 1 head? And we might say there's 6 heads being flipped. Well, we'd ask you to do 1, 2, 3, 4, 5, 6, or you can do the probability that x equals 0. 1 minus that. Cool? Just be aware of those situations. Now we're going to pull out a calculator, and I'll teach us how to do this on our calculator.